Welcome everyone to the ABCD-GIS presentation for March. I'm Jeff Blossom with the Center for Geographic Analysis. And today we have Devika Kakkar and David Smiley. Devika is a Geospatial Engineering Fellow with us at the center, working on several different system development projects. David is a freelance consultant, software developer, focusing mainly on search technologies with Apache Lucene and Solr. And today they're going to talk about the Billion Object Platform. So I will turn it over to you guys.
Great, thanks for that introduction. This presentation, I guess, is a bit of a, it's not totally a dry run, but we're also planning to give a very similar one at FOSS4G conference in September, is it? Yeah. August. Yeah, it might be off. About a project that she and I have been working on called we could just call it the BOP. I wouldn't get too hung up over the word billion in there. It's just a platform with a lot of spatial objects in it.
It could be bazillion.
Bazillion, I like that because then it makes it more tongue in cheek. Maybe we should run with that. In fact, I never even really type out billion. I just don't even. It's just the BOP. So here's how we're going to approach this. A bit of an intro. This is an architecture slide that I think is key. It's going to tie in the major components. And then we're going to proceed through those components and talk about what's involved in each of those parts. Kind of wrap up the end with some pictures of the client interface and I'm sure a little bit of demoing, depending how much time we have. So the official requirement statement is in a brief little summary is right up there. I encourage you to read it. It's very short. We're putting a billion in this particular instance of the platform. It is ultimately open source, and you can put however many in there. It's as few as great as you want. And depending on the hardware and configuration, it will be as fast or as slow, depending on all sorts of factors. But it's a lot of spatial data. I think anybody would say that's a lot. And we have a goal of real-time search. So there's two ways of looking at that. What's meant there with a 5-second latency is that when a tweet is tweeted, that we can get it into the system and have it be searchable within 5 seconds. We've lately tweaked that back up to 30 to allow for queries to be faster than they might otherwise be. The goal is sub-second queries. We're not there yet. It depends on a lot of things that I'll get into, including heat maps, which is a big part of the system. And I'd say overall, this is kind of on the cheap in my perspective. There's no redundancy, and we're not going all out with hardware. We're putting in just enough, I'd say, to do a competent job at these things. So we can't solve everything with just hardware. Just make it faster by throwing crazy fast machines at it. That's not really on the table. We have to solve it with reasonable machines, I'd say.
So BOP is a collaboration with Harvard Dataverse. BOP will be available as a new kind of data set within the Dataverse system. Basically, we have been harvesting tweets and we have been archiving tweets. So we'll have the latest billion, that will be the live system, and it will be available for query as well as for exploration, approximately 3 months of data. Then we have an archive, which currently has a manual access. But in future we will be automating it. So it's it's available to reproduce whatever you see or discover in the live system later. Our initial focus is on geo-tweets, but later in future we will be dealing with other kind of streaming data sets. About 1 to 2% of the tweets are geo-tweets. Currently we are getting about 1 million per day. And CGA has been harvesting tweets since 2012, and we have an archive of about 8 billion objects currently. Then we have researcher Ryan, who has been harvesting tweets on his end, and currently the BOP system is loaded with Ryan's tweet, but later we will be merging it with CGA's archive. And this project is a collaboration between Harvard Dataverse team and BARI, that's Boston Area Research Initiative, and this is being funded by the Sloan Foundation.
Okay, this is a big picture of the architecture. System, I think of it as flowing left to right. in terms of the data. So we harvest data, we capture it. We're going to go into these in more detail for sure. But just a little overview here. We capture the data. We call that harvesting from when it comes into our system. We enrich it. So here we're just literally grabbing it and moving it along. Here we enhance the data. We calculate some things, and we add information to the record, if you will. We store it into Kafka long term, and we get it into Apache Solr, where it's searchable. It's not really searchable in Kafka. It's more there for archival purposes. And then we have a web service in front of Apache Solr that provides the search, the faceting, all these kind of capabilities. Capabilities that Solr can do, but we've defined the interface that we want to support with the web service. And on the far right end, we have a browser-based UI. It's completely modern front end that talks to that web service, which in turn talks to Solr. So there's the indexing side, which ends at Solr, and then there's the search query side that ends at Solr as well. And we've configured it right now so that Solr has a rolling X number of months, and it's set up to be something like 30 months. We picked a number such that we get it to about 1 billion, so that we can demo it, because we said we were going to do 1 billion, so it's 1 billion. But you can obviously configure such things as you like. And the data flows via Apache Kafka here. So this that arrow is not a direct call. It's not a. Here's the thing. It flows into Kafka in and out here, and so this sort of duality here with Kafka. Data is flowing via Kafka, but here we're actually storing it long term. And once we read it into Solr, it's no longer, at that point, the Kafka story ends once it gets to Solr. And on that end, it's a request response. You do a search, you want results back. So HTTP, RESTful, I'd say services over there. There's also some, I don't know to what extent it'll show in this presentation, but there's some, let's say, what is the BOP? Is the BOP this entire thing, or is the BOP just that end of it? I'd say the BOP proper is definitely this, but sometimes we just refer to the whole thing as the BOP, even though it's, you could say it's the whole thing is a geo-tweet platform. And anyway, hopefully that won't be too confusing. And we host the entire thing on some servers run by what's called Mass Open Cloud, and they provide it for free for us because our project meets certain characteristics, which is great. And we in turn, and you can think of Mass Open Cloud as sort of like almost like an Amazon EC2, but a private instance sort. It's not Amazon, but it's they give us a web interface to manage these things. And we've in turn used Docker, managed by Container, on the OpenStack-based platform to deploy everything. So a bit more on Kafka. Kafka is I'd say it's a very modern message queue system. I'd say the more classic message queue systems would be IBM MQ series, ActiveMQ, RabbitMQ. There's a whole bunch of things out there that say MQ in them, and those are classic message queues. Kafka is a sort of a rethink of that semi-standard software, piece of software that is oriented around very high scale, high volume. So it has some really nice characteristics, although it doesn't have certain ones that are useful that a classic MQ has. So it's basically a messaging platform where data comes in, it goes to disk, and it comes out to a consumer. So you put data into a topic, just a named collection, and it's consumed by consumers. So there's some useful APIs with it. One downside here that I didn't like about Kafka is that there's no what's called back pressure. In other words, if you're producing into a topic, and if you have a consumer consuming from that topic, you can't. They don't know about each other, so you have to be mindful of. You don't want to fill that topic faster than it is being consumed, because eventually you could potentially run out of disk or something. So you just need to be mindful about that lack of a feature. But on the other hand, it's extremely fast relative to classic MQs. And one non-obvious use that we're using of Kafka is we're using it for archival storage. this was kind of hinted at a little bit at the Kafka documentation is super long, and it has some various use cases, and this is sort of hinted at, but it's a rare use case. So we're using it in two ways. Some topics we use as in and out. We harvest, we put it into a topic, and it's consumed by enrichment, and it goes out. We also consume it off into Solr. But we also have an archival topic that is not designed to be temporary, it's designed to be held long term. And we've done that by time partitioning the topic, as opposed to just letting Kafka handle it. So we have some topics that are pretty huge that are designed to keep, basically we're using by-month partitioning. And Kafka is, it's pretty cool, but it's not a database. Don't even ever think it might be one at all. It's very much a messaging system or something you can put records into, but you can't really get anything out by a key. You can't query it. You can only suck it all out, basically. So you need things like databases or Apache Solr or other things to really search your data.
Okay, so we are doing some real-time harvesting. The source code is in Python and is currently running as a container service on Massachusetts Open Cloud. So basically, we use Twitter streaming API to connect to Twitter, and then we stream tweets based on predefined user and bounding box. If we check if the tweet is a geo-tweet, then we send it to a Kafka topic, which is later consumed by the enrichment.
Enrichment. So here we consume from a topic. This happens to be the same topic that you saw on the other side. It's just the same named cylinder. These topics, by the way, these kind of topics are configured for by default, and we left it this way. It's basically weak. So one, I should say an important, like why use Kafka? What does it really give us? Well, it gives you the ability to decouple these things together. Like let's say enrichment fails, bugs, whatever. Maybe the system goes down. It decouples the harvesting from the enrichment from the consumer. So this allows us to fix the problem, and we basically have a week to fix it because this is configured. If you don't consume this data in a week, you start losing data. So you're mindful of that, and you can fix the problem, and it gives you time to deal with it. So we have two types of enrichment that we do. We do sentiment enrichment, and Devika will get into that a great deal. And we also do reverse geocoding, which is taking a lat-long point and looking up which administrative boundaries are associated with that, and basically putting that back on the tweet object. And this is done using a JVM language called Kotlin, and it was fun to work with. And we're using the Kafka so-called Streams API, which was pretty cool to use. And the deployed environment for this is kind of interesting. One of the benefits, I'll get to later about Docker and Container, but one of the things that we did is we needed to scale up enrichment a great deal, because enrichment, the sum total length of time it takes to do all that is about 20 milliseconds per tweet. But if you consider the rate at which it comes in live is totally doable, but on one machine. But the moment if you want to re-enrich your entire back catalog, that's going to take some serious horsepower. So using the Docker-based platform and the ability of the cloud, we can basically add more machines. So we asked for, please give us more machines, Mass Open Cloud. And I said, oh, okay. And so one of the machine types was a 16 CPU, now I want to say it's twice that, 32 CPU beast with 16 gigs of RAM. I could say, okay, 3 of those, boom, boom, boom. And the next thing you know, these things were sucking on that data and flying. It was flying through the system pretty darn fast. I think, did we get up to maybe, I don't know how many tweets per second we got up to. I forget. I'll think of it later. So the cloud enables us to scale up this. Okay, more on.
So one of the enrichment we are doing is finding the sentiment of each tweet. For this, I designed a Twitter sentiment classifier. Basically, it's based on support vector machine and with linear kernel. The source code is in Python, but again, we Dockerized it and containerized it and so on. And it uses the Python scikit-learn, NumPy, and basically Python natural language processing tools. For currently, it classifies two classes of sentiment, either a positive or a negative sentiment. I have used training corpus, which are open source. One is from Stanford, Sentiment 140. The other is called Polarity Dataset, and the third is from University of Michigan. Then I do a sort of pre-processing on the tweets before I really go and predict the sentiment. That is working on the lowercase, the URLs, the user name, and the hashtags, then sort of repeating characters in the tweet, emoticons. Then it is followed by stemming. I'm using Porter Stemmer to do this, and one of the main requirements was how fast can we get the sentiment enriched. And currently, if the tweet has no emoticon, it takes about 5 seconds to do everything, because it simply decides the sentiment based on the emoticon.
Milliseconds.
5 milliseconds, sorry,
okay.
To take the to do it. If it has no emoticon, then we go into whole processing stuff, and it's about 20 milliseconds per tweet. And the F1 score and precision of and the recall of this algorithm is about 82% right now with this kind of speed. So it's pretty good. Then basically, this works in two phases. In the first phase, I train my classifier with the training corpus, and then I dump it as a pickle file so that I don't have to do the training again and again, because training takes more time than prediction. Then in the predictions phase, I just load my trained classifier, and then for each incoming tweet, I parse the tweet, pre-process it, stem it, and then it goes directly to prediction.
So there's two types of enrichment we're doing. This is the second part, geo enrichment. What this really is taking the latitude longitude from these tweets. And again, not all tweets have this, but the tweets in this platform do. We call them geo-tweets because they do. We take that lat long, and then we look in 3 reference data sets. We have the well-known admin 2 boundaries, basically country boundaries, and some other major ones. We have ones for the states, and we have some more detailed one for Massachusetts in particular. And the way we basically want to look up in these data sets, and for each one, we're basically getting the name of a country, the name of a state. Maybe in Massachusetts, it's the name of some census boundary. And around the world, there's lots of data that we have. And in fact, these are the number of features, each feature meaning basically a polygon. And with the raw size. And the way this task was solved was to use, so I used Solr in a different way that you saw in the main diagram. So there, in the main architecture, Solr was a major part for searching in the BOP. Here, we're using Solr embedded within the enrichment, if you will, with these 3 data sets indexed, these polygons indexed, and we basically looping through each one and say, here's the lat long. Do I find any here? Do I find any here? Do I find any here? And I take each one and I attach it to the document. And it's basically a point and polygon query.
The reason U.S. states is 74,000 is that census tracts the country. So everything knows what census tract it's in, which opens possibilities for future knowledge.
Oh, okay. So perhaps just even say parentheses census there. That would be more, okay. This is a one-time job for indexing. It's interesting how long some of them took. One of them took most of the day, but the other ones happened super fast. I think I have theories why, but so there's some Solr tricks that I'll now for doing fast point and polygon queries into Solr. I very much optimized and used every trick I could think of to make sure this is as fast as possible. Because again, every tweet coming through we need to do these lookups super fast. And I think this part of the project was extremely successful because the 3 queries are sub-millisecond each. So boom, 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 it's done. But by and large, what takes the most time during enrichment overall is most definitely the 20 milliseconds, the 5 milliseconds that Devika just mentioned. Okay. So thinking back to the architecture slide, we harvest tweets, we enrich it, put it in Kafka long term. I've already mentioned Kafka. And finally, we need to get it into Solr. So what is Solr? For those that don't know, it's a search server, an enterprise search server, and it's based on Apache Lucene. So its main original focus was, I'd say, keyword search, especially Lucene. But when Solr came along, it added what's called faceting, otherwise known as faceted navigation, or some people just call it aggregations. And that's where the kind of the analytics come from, which goes hand in hand with keyword search quite nicely. And we've added some, I basically worked on a few different kind of add-ons to Solr. So one is time sharded routing, and we do this at index and query time. So Solr can natively shard its data and put the documents, it's not random, but it more or less, from your perception, it would seem to be random. And if you have time-based data where you're going to keep the last X number of days or months, whatever time unit, you really want to kind of manage it yourself, because you want to be able to basically have time sharded collection. So we're doing by month right now. So we have time sharded routing for the documents coming into the index at indexing, and at query time we do it as well, because if a query is only searching for certain time months, we only search the shards for those time months, not the entire collection. That was done just recently. So that's very much there for the purposes of the BOP. And it's also open sourced in a spot that can be used by other people that are interested in it. It's very much a plugin to Solr. Then there's lat long point spatial field. So Solr natively has geospatial search capabilities, but we wanted to take advantage of recent improvements in Lucene. So that's what this is about, and this was open sourced, and in Solr 6.5, which is release candidate, came out like yesterday. It'll be officially in there for everybody. And it's basically, it's not any new feature per se, it's just about doing it leaner, better, faster. And heat map spatial field is not into the Solr project yet, but all the components are open source, and there's several parts of it, so it's taking longer. So this was done. So Solr has heat map capabilities. If you don't know what that means, we're going to show you pictures of it shortly. It's basically a grid of numbers. And over a year ago, since over a year ago, it has had a heat map capability, but here I basically changed it to, I created a new way to do it. That is, the existing way was leveraging the existing spatial indices and using it for a new novel way. So it wasn't designed to do heat maps to begin with, but this is a new field in Solr that is designed for heat maps. So it gives you more flexibility, and it should be faster. And here's a picture of, on the right, a snippet of the Solr admin screen where I see the name of the collection. I see all the shards. I think there's like 31 of them. There's each shard has a name, and it's named by the month. And on the far right, it tells me which node of Solr is hosting that particular shard. It couldn't fit all on the screen. You can tell it's truncated off. Already mentioned before that Solr doesn't do time sharding built in. You have to kind of do it yourself. So that's what this is about. So Solr exposes an interface to search it, a web-based. It's an HTTP interface. You could say it's RESTful or not. It's debatable, but anyway, it already exposes a search API. Some people just use it directly, but in this case, we wanted to create. I want to get into why we created our own search service. Basically, we wanted to find a supported API, because this is going to be possibly, in fact, it's starting to be used by people other than us. Us meaning, so we have a client that we'll show you shortly. That is the main client that of the BOP, but there's another group that's already starting to use it. So the moment you let people have at the direct Solr, there's no ability to support changes that you're doing in the schema. It becomes a mess. So we define a supported API that's also more convenient and easier than Solr's native interface, because you're only defining the features that you need to support, not all the possible features that Solr, in use cases, Solr is trying to support. So it's easier to use, and for security purposes too. We don't need to worry about putting Solr on the web. So it's got keyword search, an obvious typo up there. Faceting, which is aggregated counts, and we do that on time and space. And we have a CSV export feature as well in the technology. And there's a glimpse of an interface that the Swagger technology gives us. So behind the scenes, there's what gives us the nice kind of pretty to go search the thing. That's called Swagger. The code is all using the Drop Wizard framework. It's written using the Kotlin language on the JVM. And maybe you'll put this maybe?
So I'll talk about the Bob client UI. It's being built by Ariel and his team. It's the browser side UI, and the backend is in AngularJS, OpenLayers, and NPM. And it's quite adaptable. It adapts to laptop. It can adapt to tablets and also to phones. Then it offers some of the features which I'll discuss. One is time filtering or temporal filtering, and one can go and select the dates for which you want to do the search and get the results.
I've got a question. I'm just out of curiosity for the time filtering. How is this data all captured Greenwich Mean Time? How is the time stamped? Is it stamped by local time, or is it stamped by I use like a Zulu, a universal time?
It's definitely stamped by Zulu, but yeah. For the not for official purposes, but for experimentation purposes, I took the time of day, and we're actually indexing the hour of the day. That might be useful for some purpose, but I wanted it because I wanted to experiment with calculating analytics on things, and there was no field that we were already capturing that had certain characteristics. So there is a time of day, an hour of day, I should say.
Okay, so
that might be useful.
Local time plus a planet time. So
yeah, I wouldn't say that there's a local. You could derive it. Is there a use case you have in mind where you might want to use it? No.
I'm just thinking how you skew your data if you're looking at a specific time bracket of 5 to 6 p.m. Zulu, you get a very different. Some people are awake and some people aren't. How does that skew your data?
Yeah. If you wanted to do time of day analysis, like when do people tweet about whatever topic,
right?
The data is indexed to allow that. Unfortunately, it's not exposed in the UI or the web service yet, because I had some foresight that it might be useful to capture. It's actually the minute of the day, so there's some granularity there. But that's all Zulu time there.
So we also have integration with Dataverse here, and can be exported as a CSV using the export button in the bottom, and then we can play with the base maps too. Then we have time faceting or the histograms, and one can select based on time as well as the count of tweets from the histogram.
You can get a sense of the distribution of tweets over time. There should be some big caveats, by the way, with this data set. For reasons that aren't completely known, the volume of tweets that we got out of Twitter was a factor of 10 times larger in 2014 and before, and all of a sudden it came down hard. We don't know why. I don't know. There's a couple months also in the BOP right now. There's some data gaps, certain periods of time where we know we don't have data, but we have it, but it's not in the BOP yet because of certain reasons.
I think we'll be filling in those gaps soon with our archive. Whatever gaps are there will be filled up in the next step. Oh.
So here,
you want to say something? Yeah, please.
I don't know if it's the last slide where I should keep. I can mention all sorts of things.
Okay. So we have space filtering. We can go and look at a location by zooming in on a location, and space faceting or heat maps by keyword search and so on.
Yeah, a little bit more on that. So what you're seeing, so at the Solr end, Solr returns a grid of numbers, a regular grid. And then at the front end here, instead of showing a very blocky-ish kind of heat map, it's smoothed using certain algorithms. Do you know which one? I forget. I think you know, Ben.
Well, for color mapping, we use checks.
Okay.
In terms of the JavaScript coloring, I don't know what the name is.
Okay. Yeah. So it's smooth. So the actual another thing, the data we're asking Solr to return some pretty high density heat maps. Like these are typically 4,000 is pretty typical. We actually the queries to Solr, I've seen them ask for up to 10,000. It's possible to get nearly that sometimes. So it can vary a lot. The technique on the Solr side is to basically the grid squares are more or less bucketed. The data is bucketed by grid square at indexing time. So there's some pros and cons here. The pro is that it enables search to be faster than it otherwise would be because everything's already bucketed by grid square. On the other hand, if you really wanted to be super precise about the nature of your grid and exactly what like you don't get that, you don't get a lot of choices.
When you say grid square, I mean, doesn't that change at different scales? And is there a global grid that it's hooked to? Which system?
Yes. So this is, I mean, right now it's Mercator. Okay, that's not ideal, obviously. But I think we make up for that, by the way, because it's so high density that you can sort of, I mean, once your heat map is so high density, that's less of an issue because whether your grid squares are more rectangular-ish or whether they're more squarish, once you get high density enough, it starts to be kind of in the noise of things. So that's the projection, and basically the world is divided into 4 and into 4 and into 4 and into 4, and so at a certain point it becomes materialized. So there's no grid that is literally a quarter of the world. It's basically it's truncated up until a certain point where it becomes useful. It's to save space, and then at that point, every square is divided into 4 and it's materialized, and 4 materialized, and all the way down to a certain point that's something like 5 meters. So it's a lot of data.
You got the buildings and cities.
Right. So there is a trade-off here in this approach because the grid squares are computed up front in advance, and because they're always a fourth of the next, depending on your zoom in, your zoom out of the UI, you might hit a certain level where we decide to give you the next grid square level the next. So the grid squares, if you don't want many grid squares back in the system, if you want them to be bigger than usual, you'll definitely notice a spot where they become smaller or bigger. But if you ask for 10,000 cells, you probably won't notice because it's pretty high fidelity as it is. There's a question.
Yeah, when you generate the grids, is it in certain sections? So are the grids in equal area?
It's not equal area. There's a possible way to improve it. I don't think that would amount to code changes. That would probably amount to more of configuration. But right now it is a Cartesian, what you call it? Plate Carrera. It's called that sometimes.
So you're using that long
Yes.
directly as your point.
Yes, I know it's not ideal, but on the other hand, if you ask for a high density heat map, I would submit it. The distinction is less relevant as it would be if you want more blocky, more bigger.
No, what I'm saying is that when your grids are not the same actual land area size, so your count per grid, right? Your heat map really is just the number of tweets falling into each grid, right?
Yeah.
So when your grid is actually less of land mass, even though the same size in your grid system, right? Then your count is not the same unit.
I wonder if that concern would be more. One could say it's up to the. One could say that the heat map should, the data at the time you bucket it should account for that in some way, probably using Gal Peters or something. But you could also say that maybe it's up to the front end to recognize that this grid square covers more land than this other grid square. Because the front end knows that. It's not like concealed or hidden in any way. One could say it's up to the front end side that is the browser side that's actually blurring and making it look a little bit more pretty. You could say it's up to there, but it arguably should happen somewhere because I think you have a point because it's possible depending on how it decides when something becomes red. It's possible that it may.
I mean, if you're looking at the North Pole, right, that would make a big difference. But
Big difference.
the equator is not going to make any difference at all.
So it would be lower altitude, very close to the equator. Things would appear to be then more higher density.
The more zoomed out you are,
The more zoomed out, the impact would be more severe. When you're really zoomed into local area, probably
you would notice
not
it.
at
Yeah.
all. But when you're zoomed out pretty far, then places near the equator would have actually bigger landmass in each grid versus the high.
And that will be important to take care of if this moves forward and becomes, and this visualization, which right now is really just, we can see that kind of as seat of the pants, show you the basic path, show the research, give the researchers a hope of finding where the stuff is, right? Give them a basic idea of the distribution, the idea that eventually, you know, with the right client-side JavaScript, this could even move toward, you know, kernel density type maps with a
Exactly.
proper legend.
Exactly.
You know, you could even
Yeah.
be representing
Right.
actual sort of analytic
Yeah.
views with this, but that's
So-
a couple
All
phases.
you
I'm
need is
thinking on my
a
feet
good
here.
disclaimer.
Yeah, it's not even a little bit blurb of text. It's almost like more information, and then here's the gritty details that researchers would care about. I was thinking a bit more of this on my feet here. I do think it's up to the front end, because the front end is trying to blur and make it look a little pretty, and there's probably in there some sort of radius that it decides to blur by. If that software on the front end, not the back end, that's making the decision, the front end is making that decision, hopefully it could know, okay, what latitude, longitude is this, and how much land am I actually covering by this? Hopefully it would do blurring by actual distance, not by number of pixels, say. Because that would make it sensitive to what you were getting at. Because you want it to aggregate by an actual distance or area, not by latitude, longitude.
Well, if you're actually needing to come up with an algorithm to blur the picture, it might be more worthwhile. I don't know, Ben, you can correct me, to actually use kernel density, because that would inherently have the blurring effect, right? Instead of you're coming up with an algorithm to do blurring.
Yeah. I mean, I think ultimately it'll be thinking, you know, what if we get to that point and somebody wants to do it, it'll be probably some combination of server side enhanced flexibility along with client side stuff, I'm guessing. And you could imagine users wanting to be able to do this in other projection spaces, right?
Mm-hmm.
I mean, in a way, each projection space kind of requires that you do that equal area stuff differently. That should probably be happening on the server. I don't know, but
And also this isn't a geographic coordinate system anyway. This is a web.
That's a web map.
Mercator, right?
Yep, that's right.
Yep.
So your grids are not in web Mercator when you create the grid. So there's
That's right.
that discrepancy
Right.
in the
Those,
visual,
the
too.
underlying grid squares will be variable on this,
Yeah.
because
Exactly.
the grids are on the Solr side
Mhm.
are ultimately plate carré. So therefore it's lat long, you know,
So
lat long. So
Yeah.
in a lat long world, they're all nice and square. But if you were to take those actual underlying data, if we were to actually look at the actual counts, and actually if we were to, instead of making it look like a pretty little circular thing, if instead it was literally a square with a number on it, that would not be an X by X. It'd be rectangular. It would be more squished, or it would vary.
Yeah.
However, those are some pretty high density heat maps.
Mhm.
So the distinction becomes less. I wonder how much it would matter.
It depends on who you talk to, I think. But this is already great, very helpful. The thing is that you want to explain these things in the proper terminology so that people who has the knowledge and care about it know the assumptions behind. I'm not saying, you know, revise your code and do this and do that. I'm just saying if you if you tell people how these are computed,
It should be
and
computed.
presented, then they can adjust it.
yeah, a room of NASA scientists will ask those kinds of questions. A lot of science folks.
Oh, a lot of
Yeah.
Geography people.
A lot of geographers would have.
Right. So I'm not surprised to have gotten it. You know, you're not the first person to ask about projections about these things. Okay, we have more here.
Yeah, this one.
That was spatial faceting, text faceting, tag cloud. This is opt in, you have to activate this feature in the interface to trigger it because it's particularly slow. Basically, it's finding, here's an example. What was the word used? Sorry, I'm lost for words here. Do you remember this one, Devika?
I think also on the username.
There, it's just all the.
Popular-
All the users'
Okay,
name suggestions. Yeah.
Thank you. So it, in a certain area, it basically gives you the certain ways of displaying it. This displays it as a list. This is a list of users that are in this area that occurred most frequently. And there's other, I'm not sure if it's on the screen here. Oh, these are words. So it also shows you the most frequently occurring words. So as we were using the system initially, just seeing what's in this tweet data anyway, it was all kinds of job posting sort of stuff.
But if you had a keyword, you could then click suggestions and you find all the most common words that are associated that are in the same tweet with that word you used. So if you type Trump, you might get Melania. Other things.
Right. Maybe next. Right, so this is a distance sorted order from the center of the screen. Right, and next. Okay, back to deployment and ops. So this is deployed to, I've mentioned Mass Open Cloud. It is an OpenStack based cloud, which basically, if those that don't know, once you've seen and used Amazon EC2, you see OpenStack, and it's clearly the concept was ripped off and put in an open source package, and Mass Open Cloud has deployed it to give us a web interface to manage the servers virtually. On each of the servers we get, I deploy what's called an operating system called CoreOS, which is a rather interesting choice because it's rather new. It's just designed for Docker environments. I didn't have to use CoreOS, but it's been an interesting one. And we use Container and Docker. For those that don't know, Docker is a container-based view of how to deploy and run software. There's another slide on it a bit later. And once you really get into Docker and you've played with it on your own machine locally, if you really want to deploy it for real, like you want to run machines on Docker, then you need a way to orchestrate your containers, and Container does that. Provides lots of nice capabilities, like unified logging, for example. Like from the command line, I can bring up the logs on all my Solr instances in one big, nice flow view. And so when something goes wrong, I can see all the servers talking to each other and what's happening. So it's quite useful for many things. It also will restart services when they fail for some reason. So we use, when we're running the system, sometimes we'll use Kafka Manager to see how fast data is flowing into topics and to delete them. I use Solr's admin UI just to get that heads up view of, how are the shards doing? Something's yellow, I can see there's a problem. And the stats. So we have 12 machines. 5 of them are running Solr. They're also running, some of them are also running Zookeeper. 3 of them are running Kafka. And it's so many because we're using it for archival. Otherwise, we'd only need maybe 1 or 2. And we have 3 for enrichment. We only really need 1, but we're trying to put in 1 billion in a short amount of time, and we need to kind of scale up the resources to do that. And there's another machine or 2 in there too for some miscellaneous purposes. There's a lot of RAM, especially because of Solr and also for enrichment, which are high RAM consumers. And there's a lot of disk there. Most of it is for all that archival data. I think the average kilobyte per tweet is something like a kilobyte a tweet based on how we compress it with using message pack JSON and other stuff. 17, those stats are coming from Container, which gives me some statistics here. So 17 what are called services, and that's basically a piece of software. It could be one that we wrote, could be one that we're using off the shelf, like Solr. And those are instantiated multiple times. For example, so that's why there's the 133, because, for example, every node has certain services that Container itself uses. I'll move on now. Docker is pretty amazing. And I really think it's a sea change in deploying software and trying out software. I highly insist those technologists that like experimenting with new things to try Docker if you haven't already. It's particularly awesome for trying out new things, and it's also for continuous integration. It's relatively new, so it's starting to be used in production more and more, and there's certainly production advantages for it as well. There's a lot of nice things about it. It provides one simple way to go about trying and using anything and keeping that thing contained. So, for a random example here, in the Geo Enrichment, I need to get those 3 data sets and put them into Solr, all that polygonal data. So I had shape files, and I needed to convert it to WKT, and I need to put it in Solr. So I needed to use something called GDAL, which has an OGR to OGR tool. So instead of installing that, figuring out, it would probably, I'll say infect my system, but I don't mean that really in a bad way. I just mean it's gonna put stuff in places. It may not even be the right version, maybe I need to change it later and I'll forget. By using Docker, it's just all contained. And it's not all over my system. It's really very much in like a little micro virtual machine in a sense. It's like a micro virtual machine. But micro doesn't necessarily mean like it's not necessarily using a lot of resources. It means they're easy to start as opposed to conventional virtual machines. If we're going to bring it to production, you need a system to orchestrate it. So we use Container. There's a system called Kubernetes that is more well known, but it is much more complex. Container is focused on smaller organizations that are trying to manage, maybe 100 machines, but not tens of thousands, like the likes of eBay and such. It's kind of one nice interface that has a bunch of capabilities. For example, we need to keep track of credentials to access Twitter. So we have API keys, so it has places for you to manage your so-called secrets. Common logging is really useful. And it will restart services that fail just by itself. You don't have to worry about that. So once you start embracing Container, you probably don't need anyway, Ansible, Chef, Puppet, things like that. For the most part, Docker handles these things with Container. Handling state, I'd say, in Docker is kind of a challenge, though. That's one of the weaker areas of Docker where it's more awkward. And that is it. We could bring up the interface if there's time. Technically, this goes to 1:30.
Yeah, thanks a lot, guys. That was great. Yeah, we have the room till 1:30, so we might as well do questions. If people need to leave, then that's fine. But yeah.
Is there a demo that we could see?
Yeah, let's do that.
Okay.
I'm very sad that the system is not as real time as I'd like it to be. We would like it to be sub-second queries. We'd like it to be. Now, so there's a couple of challenges. One is that, remember, the data is time sharded, and we discovered sort of after the fact that there's this massive drop in tweet counts per month after 2014. So needless to say, we've got one shard or two shards that are like 140 million tweets each. And then everything else is like maybe 20 million or maybe 10 million in there. So the moment your search includes the biggest shard, you're gated by how fast the biggest shard can do its job. So it helps that we have time-based routing to the shards, such that if your query does not include that time range, if you have a time range filter, we at least no longer send your queries to the biggest shards, which is helpful. Are you asking a question?
We can do some search.
Never mind. Sorry?
We can do some search here.
Right. So that's one thing.
Yeah.
There's certainly some more tuning that could happen.
You said it was 2 to 3% that had GPS coordinates?
Did you say that? I think that's right.
So currently it's about 1 million per day, but it used to be more, and about 1 to 2% which has geocoordinate.
Is that the current state, or is 1 to 2% the current flow, or is that did it used to be 1 or 2%?
I think.
I don't know. Or maybe it used to be both.
It's low.
So
Yeah.
Okay.
Right.
so currently about 1 million per nowadays. It's the current, but in 2014 and 15, it used to be more. But generally, it's 1 to 2%. That's what Twitter says, that 1 to 2% of a total fire hose is what geo-tweet is. So that's, I did a keyword search on Trump.
And you're right now, you're filtered to 2017.
Yeah. So I think I'm filtered to, yeah, from January 2017 to March 2017. It's a 3 months window on the search, I think, on the exploration.
Zoom in on.
Yeah, that's the.
So as you zoom in for a moment, you see those, you see the circles there, but it's recalculating a heat map that then gets better. So for a moment, you can get a sense of how dense the underlying grid was for a moment before it redraws. I think is it redrawing right now? No, I guess it's that low.
Done. And then I think we can do time faceting on the tweet counts.
Are Trump's tweets geolocated?
These are the tweets which contain the keyword Trump, but they are not from Trump. I think his tweets are not geolocated. Yeah. So if I go to the user handle and say,
it'd be awesome if they were. But
yeah. So if we try his user handle real Donald Trump, then we don't get anything because I think they are not.
Yeah. Yeah.
So that's the thing. And
Zoom in tightly to a city, you get a lot more.
okay.
Sense of.
Oops. What's that?
this is real Twitter data. It's not scrubbed for, I don't know, bad words or anything. So if you see something you don't like, sorry. It's Twitter. This interface looks like you've zoomed in on the, like you took a browser. It looks like you've, like the controls are gone.
Yeah, and that's what
I've accidentally done that on my own machine before by accident, but not yet while using this.
Okay, maybe I'll open it.
That's what API? Web map API is it? I mean, it's Google Maps layer, but what is it? OpenLayers?
OpenLayers, yeah.
OpenLayers.
OpenLayers, yeah. So. We also have a suggestion.
What's with Trump in Western Africa?
I don't know.
And what if we try a different word like drones or?
Okay.
There are definitely a lot of questions about the data. It's not hard to say, why is that? And you dig in and it's like, also a lot of the data is very, this is geo-tweet data, not just all Twitter. So it seems that geo-tweet data is far more likely to have certain bots that tweet. So I think it's worth saying, you know, how might we potentially maybe filter it out in some way? Because it might skew.
I was just looking at, so you
Lagos.
see Gugun's lulls there.
Yeah,
And that's showing up a lot on the left, but it's only, I just was looking at this morning, all the bots that are out there, and they're these strange tweets that are coming, that are bots, and all they have in them is a giant long hash in them.
Yes.
And they're random. If you type
Well, you
Gugun's
think they're random.
lulls, you'll get it across the world. But there's only, it's about 1/500th of all the geocoded tweets are coming from bots. So even though they show up quite a bit on this is something we need to think about at some point. Maybe we want to, because it's Solr, we can do things with weighting probably, and everything that's a bot we might give a weight.
Yeah, in terms of ranking the search
Less
results
likely
back.
to come back and-
But in terms of heat map, it's
Right.
yet another count.
Right.
Oh, we never got sentiment heat maps. So, and I don't think it's shown here. So one important thing that we wanted to try was to be able to, like, how do you summarize the sentiment? And it's not seen here, but essentially on the Solr end, we actually have a heat map grid. We have two. We have one for everything, and one that's only the happy tweets or something like that. So it allows you to take a difference. It allows you to to potentially analyze, take one heat map, subtract it from the other, take a ratio, and now you can get a sense of, oh, we have higher, just disproportionate happy people or sad people in one place or the other. It enables that. So the web service API, the BOP web service, exposes that, but I don't think it's hooked into this particular interface yet. It's basically 2 grids we return. It's up to you to do something with it.
Yeah.
For the histogram, the temporal histogram, is it easy or hard to make it a toggle of zoom to the complete set or zoom to the selected? I know that you can use it to narrow your selection, but suppose you have 2 years of data in there.
Yeah.
You know, right now it's only 2 months, right? If you have 2 years of data and I zoom into a few days, right? It's very hard to control over there, but then once I zoom into the few days, maybe I want to see the fluctuation within that time range. So it would be really helpful to the end user to be able to toggle zoom to the full extent versus zoom to my selected set.
Right.
Anyway,
Right.
just a comment.
I agree.
Yeah.
I agree. So, and also another thing that I think would be useful is when you look at, so it's nice to look at the distribution of tweets over time, because that might tell you that, you know, certain words, certain searches are more popular at other times, but it doesn't tell you relative to just people talking, period. So, like, in other words, maybe the word is showing up more often at a certain time, but everybody was just tweeting more then. It doesn't,
You have to say a shadow histogram of the total tweet.
Right. And you could show it stacked, or you could show it as a relative of a whole. So that way you have basically weighted your time bars. And that's very similar to what could be done with the sentiment heat map, where you take a baseline, which is the everything, and then you basically, it's like a ratio over the baseline for that same chunk of space over
It's an
time.
extra query.
Yes.
Extra array return.
It's an extra chunk of data back. One request to Solr. Solr does a bunch of things all at once. Yeah.
Then we have suggestions on keywords. So I just searched drones, and these are the suggestions. New flyout and so on, and also suggestions on the username. That's basically the tag cloud faceting feature, which I was showing in the slides. I'll try to zoom in on a place. So if I zoom in on New York, I'm just trying to, you can see much more.
So if I want to export right now, I export only 69? Or
Yes,
export?
you just click on export and you'll get a CSV file.
Oh,
But I get
no, that's
the
CSV.
file of the 69 that I see, or
No,
or the package?
You get not just the 69, you get up to 10,000.
10,000.
And unfortunately, due to Ben's interpretation of the Twitter user agreement is such that in order for us to be really safe, because this is not authenticated, anybody can come in and start searching for data. Twitter doesn't want people going to intermediaries. They want people searching Twitter at Twitter. But that being said, it's in their interest for researchers and others. So to be safe, the export in particular only has the ID and what we've enriched. So like the sentiment and from the ID, granted, you could impute the time if you're clever, but that's not a lot of information. You can take that same tweet ID and go to Twitter's API.
That's for the public, but anybody here at Harvard and anybody working with a Harvard person can get the richer stuff directly without. And if you do get only the IDs, it's very easy to turn those into full tweets.
Yeah, with a loop.
Yeah.
You're looping over 10,000 and saying, hey, Twitter, you know. There's a batch API though. I think.
Yeah,
The
you
question
can
was
send-
about, so when you export, I wonder, you export all of them with the filter on? So like in
Yes,
this case,
Yeah.
this export takes the entire result set. This is the top X of the result set. That is the first 10,000 of the result set. So so ranked by your sort, and this is sort here.
But it's nice because they change with extent. So if you change extent, you get.
Yes, if you change your filter, your
Yeah,
filters.
So a key feature, it would be nice to have an export that also export only what you see. Let's say that you want to search for a keyword, but also for a specific area.
Right. It'll include all your filters in play, and your filters are keyword, user potentially, time, and space. All those things. Some of those might be blank because it's everything. But the moment you draw out a box, you've now added a space filter, and your export is only this is like a snippet of the top of the export that you'd see. Granted, more data here, but okay. It's always filtered to your filters you have in play: space, time, keyword.
If your query returns 9,000 tweets and you click export, you're going to get all 9,000.
Yeah.
If it's 20,000, you're going to get whatever the top 10,000 happen to be. You won't have total control over which tweets you're getting. But if you can get your selected set below 10,000, you know everything that's in your view and list is what you get.
Right. Is the tweet count here? If I look confused half the time, I didn't build the UI.
Result you'll store there.
Yeah, because I zoomed in on the place.
Yeah.
Okay. Where's the
You have
results
you
for
have
keyword?
drones,
4.
and
Okay.
there aren't a lot of people talking about drones
In that time period. That are geo-tweets.
in that. Right.
Yeah, that are geo-tweets. So
Um,
now we, because I zoomed in on the place, we already have an API with which you can use for these exported IDs to convert them to full tweet JSON, which might be helpful. So you can send tweet IDs in batch of 100 at a time and get the full tweet out of your tweet ID or whatever fields you might want to use for your research.
To the Twitter API.
Through Twitter API, yeah. So Twitter has an API with which you can get your full tweet JSON if you have the IDs. And that's how it allows export. You can give IDs out in bulk, but not full tweet JSON. That's a way to retrieve, or it's called rehydration. It's a way to rehydrate your tweets with whatever data you want, specifically for your research.
Yeah, we believe we need to do this to make sure that we don't look bad to them. They don't want to tell us not to do what we're doing.
Yeah, maybe we can show where our GitHub, where our open
Yeah,
source
to this
is.
audience, maybe the Kafka manager might be interesting.
Yeah. So,
Well, hopefully Twitter will see this and be inspired to encourage their users to turn on their geolocation.
yeah, it's sort of privacy issue there. Not many people want to turn on the location thing.
I thought about it myself, but it's like, not even from a security point of view, it's like, who cares where I am? I tweet about whatever, and where I am is incidental. I don't know.
To you.
To me, right.
Others,
I've seen security folks that love it when people in the security industry tweet their location, because then they learn cross-country intel. Anyway, topics are 4. So this is Kafka Manager. This is a Yahoo open source project because Yahoo uses Kafka internally. Go to there. Top. Just take a moment. Yeah, I was thinking. So we're about to see 4 topics, and it shows you the rates. I think that the highest rate that we were enriching was at upwards of 1,200 per second, which was largely gated by the amount of RAM we had, not the CPUs we had. Because the enrichment, the sentiment enrichment, not only does it take 20 milliseconds, but each process requires its own, several hundred megs. So that is up fast if you try to parallelize that. So tweets come into tweets real time. They go. There's two input topics. Real time tweets go in here. Tweets archive input is when we're bulk loading data that we get from somewhere. It's not from the real time Twitter. And then from both of those, they are enriched and dropped into tweets archive. That has 64 partitions, and we add more as time marches forward. That's most topics. If you were to use Kafka, you probably wouldn't use time-based, but you'd probably just let Kafka do its thing, and you pick some partition count. But in this case, we've done it for this particular topic. We've done explicit partition management, where we say that this partition 0 is month. We started tweeting. I don't know. I forget. What one?
11 November of 2014.
November, yeah. That month is our partition 0, and the next month is partition 1, partition 2. That way, we know if we get data, we know exactly where it goes, and we need to reload it. We know where it is. If we delete it, we can do it explicitly because we want to delete all of that. And this also says, let's say we want to re-enrich, reprocess certain data. It's easier if we want to send certain months to Solr. We can do that by having certain months by selecting certain months. Because Kafka, you can't really query it, but you can bucket it.
This is basically our long-term archive for now. So each of the values you see is 1 month. Currently, it has Rience data, but later we want to get our CGA harvested tweets to this long-term archive. So we don't want another space to maintain this archive. We thought if we are getting data into Kafka, why not leave it there and make it our long-term archive? This way we save some time and space in doing this.
Right now, tweets are coming in at 9.42 per second. So just over 9 tweets a second right now, real-time geo-tweets. Because that's the only loading that's happening in the entire thing. Because that's.
I think it varies during the time of the day.
Yeah.
Sometimes you have more in the evening and so on. So it's not the fixed rate, but that's an average.
Right. So that's one screen.
Kafka is a web user, a web client.
It's a web client to make working with Kafka easiser, as opposed to using all the command line tools that Kafka has. Yes, exactly. And it is very convenient. You can get a bird's eye view of what's going on. You can see problems. Let's bring up Solr. You're on the.
Should be in the bookmark.
Oh, you have a bookmark for it? Oh,
I have bookmark for
please.
This one?
Yeah.
I need to be on VPN, I guess.
Oh, yeah. Never mind.
I can connect it.
So one of the really useful features of Container, the orchestrations for Docker, is that it has a. So if you're developing conventional services, never mind Docker. You're building a system. You got multiple parts. It's all running on some number of machines out in some cloud somewhere. What if you need to go in and view internal mechanisms? You need to talk to directly to services that you don't want to put on the internet because it's internal. You would need to secure that service, or you would need to SSH to some box and do some port forwarding stuff, and it's awkward. Especially if you've got 12 machines, and the bigger it is, the more complex it is. So one thing that Container has that's really cool is it has a VPN feature. So at first I was like, I thought it might be a headache, and I didn't want to use it. But once I realized what it is, I think it's pretty fabulous. Basically, my machine, most of the time, it's on the VPN. And that allows DNS lookups, bop-Solr, to resolve as local service names on this grid. So Katana basically gives every one of my services its own DNS name that makes sense. Like it's the bop Solr, there's bop Kafka, there's a variety of the services. I just need to know that name. And I can access them directly and not worry about putting my stuff all on the internet, which I'm not ready to secure, which is a hassle and brings issues, obviously. So that's really useful. So when I'm developing stuff, I'm on the VPN all the time.
And it makes it possible for collaborators, say another university who's got a server on the web, to make that server a part of this grid.
Yeah, it's a huge feature of Container. Like we're not tied to Mass Open Cloud or anything. We could actually add nodes that are on completely other clouds, and it's all virtually networked together. So we could add resources. Like maybe we've got this beast of a machine here. What do you call it? GEOPS. If we wanted to leverage GEOPS, we wouldn't have to figure out how to connect it to the internet and secure it in such a way. We would just put it on the grid, and that virtually makes it a part, just like my computer, my development machine becomes virtually part of the grid with the VPN. So affect with any node that you want to join the collective. It doesn't mean that the communication between here and across some towns away is straight, but it enables things without having to worry. It secures an environment for you to play and operate.
When you say put it on the grid, what does that entail?
So the grid is Containa's name for its network. It's a
So
virtual network.
You're just basically saying, give me the IP address of this instance and its credentials, and you can just connect it as a node on that Container grid.
Yeah, the Container architecture is such that there's a Container master, and every node that I want to become part of this grid, I need to give it secret credentials, because obviously no one out there connected to it.
Just a container, or can
Sorry?
One node is just a container, or can even be a server?
I'm talking about servers here.
Okay.
I'm talking about a server. So once I want a server, a machine, any machine, a host, if you will, to be part of this grid, this network, I give it a secret key and a URL it needs, and that's obviously needs to be safeguarded. So then it talks to Container master, and then it's able to talk amongst each other. As long as the machines can, as long as if you're trying to have nodes that are in different actual clouds, as long as some of them can be connected through public IPs, they can talk to each other. They use something called weave networking.
Do you have to go and install some key on that instance in order for it to know?
Yeah,
Oh,
yeah, that's a one-time setup.
Yeah, okay.
I mentioned Core OS. I have a config file, and at the very top it has that. And then once I do that, boom, it's part of it. And Contena says, oh, you have a new node here, and here's its name. And it's all part of the collective. And then the next thing you know, it might schedule jobs to run, containers and services to run anywhere. But because this is big data, I don't want things running just anywhere. I have certain machines with configurations for certain purposes. So I'm often explicit. But sometimes, like Kafka Manager, that thing hops around all over the place, for example. And this is Solr's admin screen. In the cloud view in particular, where you can see a bunch of month shards. And you also see another collection where I was experimenting. And the screen itself is not very interesting, but it does tell you when there are problems. And for a while, we're doing things on the cheap to an extent. Like there's no replication. The disk on each of those nodes is barely sufficient. So at times, I've had little emergencies where I need to add a replica somewhere and delete something else to try and kind of juggle the space issues because of the lopsidedness of the shards. Certain months are huge, some are small. So I've used this screen to see, add replica and see what's going on.
Is there any particular reason that you have to keep your shards by a fixed length of time? Can't you just break down the big ones and keep or merge some small ones to make them size-wise more even?
I could do that. It would take, it adds more complexity that I didn't anticipate needing at all. In the very beginning, we were thinking I wasn't thinking that there'd be this massive disparity because I was looking at a particular unit of time and there was no talk of that. But perhaps if we should have investigated that, I should have investigated that earlier on, because when reality set in, we realized, hey, lately it's been like a tenth of what it used to be. And that means instead, I thought we would only have a few months worth because that's all we could take to get to 1 billion. But now we got back 2 years because those last 2 months are like 140 million each, and then it drops off like a cliff. I don't know why that is, but so you're right, that could be done. And I definitely think if you have time data when you're trying to keep X number of days or months or whatever it is, you need to, with Solr, you do need to do it in this way where you're explicit about you do need to do this manual sharding, basically. I'm doing the sharding manually. I'm not letting Solr handle it all. Solr can handle things all, but there's certain trade-offs that I'm not willing, that I don't want to make for this. There's lots of caching, yeah. And that's a big part of it.
And it happens at which level?
So a query has multiple aspects of it. So some things are just not cached, like the heat map. It's just the heat map is not cached. That being said, there's something called the OS cache. And if you keep asking the same part of disk, it gets put into memory and it's fast. So there's a cold start where the system will be slow. That's a given for almost anything. So your query itself, if you search for whatever, that Trump word, that's going to be the top X results given certain filters. That is cached, but it's also, there's a 30-second window we've configured. So new data comes in, and we do a commit every 30 seconds. But we also, there's an automatic replay of the cached queries. So if you're running a query that everybody's doing, it will tend to be automatically fresh immediately when the commit works. So that's true. Also, every time bar is potentially cacheable in the time histogram. So, but there's only so many. We've only allowed those caches to be so big. So it's, as you use the system, some things will get out of the cache and get back in. That's configurable. I think I could do a better job managing that, because each little time bar, those go to every single shard. So if you ask for an entire year worth of, if you wanted 365 per day counts, that's going to go to every shard, even though, obviously to most of them, it would be like an everything kind of query. So some optimizations could be done there. There's definitely more optimizations that could be done to get it faster. I definitely want it to be faster. It'll take time to analyze it and see how much faster we could get it. I'm not too sure what the low-hanging fruit is at the moment, but we've done some of the important things we needed to do, like sending queries to the right shards was key. Let's avoid the late 2014 months. 140 million each on those guys.
User inputs, or I don't know, it's probably out of scope here, but to expose your assessment damping, right? multifaceted search, sentiment being the facet, so that you could search, you know, your keyword, your space, your time, and then you could say all of it, only the happy ones, or only the unhappy ones, or do you have anything in the middle that you
No.
cannot detect either way?
It is binary.
Oh, it's binary. Well, that could be problematic. But anyway.
We could use it. We're not using it yet. It's not in the UI. It definitely,
Yeah. So
it's plumbed
adding
into
it
the system,
UI,
but not the UI. So it needs to be added there.
Yeah, yeah. So it's almost like all that much work there that you're not exposing it.
Yeah, I know.
It's,
Right.
Well,
I don't know why.
So the heat map, the sentiment map is part of this job, part of this contract. It just hasn't gotten in there yet.
In the UI.
Yeah, so
Yeah.
So it's going to show up.
the sentiment map,
Okay.
meaning you'll be able to view a heat map.
But without your own filters. It's the overall sentiment.
Yes.
So you can't say.
Instead of getting your results as a count.
Because I want to say.
Wait. No, it has your time filters. No, all your time, your keyword filters, all those filters are in play.
Oh, yeah.
Yeah, I think what Ben means is
I
you
don't
cannot search for I only want to see the happy tweets. I don't think you. I mean, I could add it, but
Yeah.
We weren't thinking that would be useful.
happy sad. The happy sad switch isn't built into the contract.
Oh, okay.
But
Okay.
the display, the optional display of the map as a map of happiness is in the contract.
Yeah.
In addition to
But
counts.
isn't it the same?
What you're seeing is what this is. This
No.
is counts.
It's visualizing the results. Like you asked, I want to search for just the happy tweets. It cannot do. Well,
No, you
We
don't.
could make it
need
do that,
to.
but-
You get all of them back, right? All of them back, and you can either show a ratio of the happy.
yeah, right. That is in the contract.
Or
That's what we're
you
doing.
can.
Yep.
Okay, well, then that's good enough,
Right.
I think. That's good
And
enough.
one thing we're not leveraging at all. So you mentioned sentiment. You don't see that in the front end. The other is the geo enrichment. Well, we enriched it so that we know what country it is and what
Yeah.
state it is, and that is just waiting to be tapped into in Solr. It's already been indexed in Solr.
It's output to people who are requesting extractions, but the whole idea was that would be a new client to be
Right.
developed
Right.
for on the
Well,
fly analytics.
that's not an easy exposure. The sentiment is kind of a straightforward exposure on the map, so that. I'm
Yeah, there's more.
kind of eager to see that.
I know what you mean. There's more to it because once you get into the geo enrichment, you have issues of hierarchy,
Yeah, that's.
and then how do I explore the data? It's not rocket. People have kind of done it, but you need to kind of look at some interfaces that you see that are similar and figure out what you want to do. But it's at least in Solr in such a way that is we don't need to re-index the data once the front end is doing that.
Another common is the text cloud, right? Right now, you have the text all listed there.
Yeah.
But if you can show, if you can
I know
symbolize
where you're going.
the individual words by frequency or something.
Yeah.
Either by size or by color.
agree.
Or by whatever.
I totally agree. Yeah.
Then it would be, you have all that, right?
Right. I don't know why. Yeah.
It's just not exposing it. So
Right.
it's a pity.
There's only
right?
so much you can do in
Right. I totally agree.
one contract.
There's certain parts that I did. So certain parts.
So the whole goal
Yeah,
was to have people say, wow,
yeah,
can it do this and this and this and this?
Exactly.
To which we say, yeah, easily.
yeah.
We just need a little.
Exactly.
Right.
That's why I'm saying that, I'm not saying that you should have done it. I'm just saying these are things that I anticipate people would say probably very soon.
Yeah.
So you might as well just make a list and prompt them to say it.
Yeah.
Right?
We know we
At the
could
end of the
display this.
presentation,
Right. Yeah.
And say, here are the things.
That the system's dying to do. Just
Exactly.
hasn't
Right.
been exposed yet.
Right. That's definitely true for sentiment and for the geo enrichment. Which has spent all this time enriching and it's just sitting in there right now.
Another thing along those lines. This thing is pretty general purpose. It wouldn't be too hard to bring in another stream and have it be 311 data out of the city of Boston.
Yeah.
Right, and have a toggle
Yeah.
on the UI, which lets you view either geo-tweets or 311 data.
What is 311 data?
311 data is, it's a
Service, city service request.
Non-emergency
non-emergency city service data.
Potholes.
Could be.
Actually, I think a lot of it does get tweeted out now, so maybe a lot of it actually
Don't they
is
have-
in here. But
don't they
let's
have
imagine there's a stream.
Don't they have an hashtag?
Yeah.
So maybe.
So
it's
that's not the best
easier.
example because it's already in here. Some of it. But another stream, right? G delt or something. We could have fewer tweets in here, and we could tweak the system so we could have the user select between, 3 or 4 different kinds of data, right? And basically making use of this infrastructure, harvest to Kafka to archive, to support a slightly different schema, which where each record has time, space, and some either data or text variable. Flickr, Instagram. Yeah, Instagram would be great.
Just to wind up.
End of our demo, I guess.
Yeah, I just wanted to show.